we'll begin with number 1. And we have 2q squared plus 5q to the 6th plus 9. And I'm going to multiply all that by 4q to the 4th. Now, there's really no difference between having this part at the end or at the beginning. It doesn't matter because it's multiplication. What we're going to do is just still distribute. We're kind of distributing backwards from what most of you have seen before. Usually the little one is up front, but this is different. This is going to equal 4q to the 4th times 2q squared, which gives me 8q to the 6th, plus 4 times 5 is 20q to the 10th, plus 36q to the 4th. We have what's called polynomials. Every term in a polynomial has to be of the form ax to the n power, where a is a real number. Any number that's on the number line is a real number, and it is called the coefficient. Then we have x is just our variable. It could be r, it could be y, it could be anything, but it's basically a variable. But n has to be greater than or equal to 0, no negatives. N is an integer, which means it's basically a whole number. And it is called the degree. Now, if I have 3x squared, I have a coefficient, I have a degree. My coefficient here is 3. My degree is 2. And this is called a monomial. It's called a monomial because it has one term, ax to the n, and mono means 1. If I have 3x squared plus 5x, this is called a binomial. It's called a binomial. Notice we have 2 terms, and bi means 2, like a bicycle, 2 wheels. Now here we have 2 coefficients. We have a leading coefficient of 3, and we have another coefficient of 5. We can say we have 2 coefficients, 3 and 5. But my degree has to do with the largest exponent. So my degree here is still 2. Even though I have one value with a degree of 1, we don't care. And lastly, we have, let's just use the same numbers, 3x squared plus 5x plus 2. Now, this is called a trinomial because tri means 3. And now we have 3 terms, don't we? Yeah. So terms are anything that are added or subtracted. 3x squared is a term, 5x is a term. So I have 2 terms. That's why it's called binomial. And both of them fit in this ax to the n. So this is 3, 5, and 2. My degree is still 2. But why is this a polynomial? When we want to know if something is a polynomial, each term has to fit ax to the n. Does 3x squared fit ax to the n? Yes, because a would be 3, x is x, and n would be 2, right? So let's say we have ax to the n. Well, here, a equals 3, and n equals 2. So each term has to be of the right form.
Okay.
It's 5x of the form ax to the n.
The 1?
Yes.
Okay.
Okay, so there it is of that form, but you know, we have lots of invisible ones around, don't we? Now, this one is really tricky, the 2. 2 is equal to 2x to the 0 power, isn't it? Because anything to the 0 power is 1. Is x to the 0 is 1. 1 times 2 is 2. So 2 is that form because I said n has to be greater than or equal to 0. And it is equal to 0. So it fits into a polynomial. Anything of that form is a polynomial if each term, these are terms. I can have many terms, I can have few terms, but anything plus or minus is a term. R plus 8 times R plus 7. And we have 2 polynomials where each with 2 terms. This is called a binomial, and this is a binomial. And a binomial times a binomial, we use FOIL. And it just helps remember. We're going to multiply the first times the first, the outer times the outer, the inner times the inner, and the last times the last. What does that mean? We have R plus 8 times R plus 7. The first times the first means this times this. The first times the first is R times R, which is R squared. This is outer and outer. We have outer times outer. We add 7R because that's what outer times outer is. Then I have inner times inner. So I add inner times inner. And then I have last times last. 8 and 7 are the last times last, plus 56. Now I've done F, O, I, L. We're going to add them together. We have R squared. Combine like terms. These are like terms. I get plus 15R plus 56. And that would be my final answer. We have first times first. Remember FOIL. It's an easy way to remember. First times first is minus 14q squared. Then we have outer times outer.
7q by 6.
Yes, which equals 42q. Then I have inner times inner. Inner times inner is these two.
Negative 7 by negative 2.
Right, so it's going to be positive 14q. And then have last
negative 7 by 6.
Right, 42. Then I combine like terms. I have minus 14q squared. I combine these two. I get plus 56q minus 42. And I'm done. That's it. This is a special case. We have something called the difference of squares. This is very important. It comes up a lot. You'll see why it's important later. But basically, if you have a plus b times a minus b, it's always equal to a squared minus b squared. So let's look and see why that's true. I have first times first, a squared, outer times outer, negative ab, inner times inner, positive ab, last times last minus b squared. Minus ab plus ab are 0, and we end up with a squared minus b squared. 7 plus 8w times 7 minus 8w. How do I notice the difference of squares? Because if a is 7, they both have 7 as a, and b is 8w, then they both have 8w as b. And then the only thing different is the signs are opposite each other. This would be a squared minus b squared, which is 49 minus 64 w squared. Now, the really nice part happens when we have to go in reverse and we have to do what's called factoring. This is different. This is not the difference of squares. We have two special cases, difference of squared. This is called a perfect square trinomial. This one, if you like memorizing things, it's a very nice thing to memorize because, again, it comes up very often. If you have a plus b or minus squared, that means if it's a plus, it's a plus. If it's minus, it's a minus. It's not both. And this will always equal a squared, and this will be b squared at the end. And depending on the sign, it's going to be plus or minus. Like if it's plus, it's going to be plus. If it's minus, it's going to be minus. And this is 2ab. Why does that work like that? Well, let's just use a plus b times a plus b. Well, that equals a squared, first times first, outer times outer, inner times inner, and last times last. I can combine my middle terms, and ab plus ab is 2ab plus b squared. These are the two special cases of multiplication. Three plus 7z squared equals 3 squared plus 7z squared. That's not true. You can't distribute the square. What this equals is 3 plus 7z times 3 plus 7z. Remember, the exponent always acts on what it's next to. This would equal 9, first times first, outer times outer, inner times inner, last times last. I combine my two inner and outer terms, I get 9 plus 42z plus 49z squared. If a equals 3 and b equals 7z, and I use the formula that I gave you above, this would equal, well, first term is a squared is 9 plus 2 times a times b plus b squared. Remember, that's what I wrote right here. So this is equal to 9 plus, well, 2 times 3 is 6. 6 times 7 is 42, z. And then plus 7 squared is 49, z squared is z squared. Notice this matches when I just did it manually. This is another special case. Don't do this. This is wrong. Notice I would get 9 plus 49z squared, but I would lose my middle term by doing it that way. A binomial times a binomial, we just FOIL.